Okay, so welcome to another video of A-Level-Up Maths. In this one, we're going to be looking at something from the Edexcel book 2, which is parametric equations, and a bit of an intro to those. So, firstly, let's just take a look at what a parametric equation is. So, the first thing, parametric equations contain three variables but only describe a 2D graph. It's not a 3D graph in this case, even though it's got three variables. And the second thing you need to know is, so previously equations for graphs, they tended to contain only x and y, and the technical term for these are Cartesian equations, versus obviously the parametric equations that we're introducing at the moment. You might now be thinking, well, what's the point of parametric equations? You know, why can't we just use Cartesian equations? Well, so some situations lend themselves to using parametric equations, e.g. for instance a ball being thrown. So actually if you have a look at maybe how a ball would be thrown, well, it would take a path through the air like so. We could call the height of this ball y, how far along the ground it is x, but actually at each different point on the graph, you could also have, for instance, a time. So maybe it would be this far along its path after 1 second. Maybe over here it would be at 2 seconds, and over here it would be at 3 seconds. So you can see for each point, not only do we have a height, a distance across, but we also have this other parameter, maybe t, which stands for time in this kind of situation. So, without further ado, let's have a look at an example. Well, this is what a parametric equation looks like. We've got x equals 2t and y equals t squared. And our first question is to plot the curve for -1, t between -1 and 3. So the first thing we need to do, because we're obviously plotting it, we need specific points to plot. So our t value is going to go, we can plot for these individual values here. And for our x value and our y value, for x value we can use our first formula here. So it's 2 times -1 is -2. Okay, and now all we have to do is to plot those values onto some particular graph paper or onto here. So over here we'll be plotting -2 with a height of 1. Okay, let's have a quick look at the next question. State the domain and range. Well, now we've got a sketch. It's fairly straightforward. The domain, it links to the x values, and the range links to the range of y values. So having a look at our graph here, we can see that the x values go from -2 all the way along to 6. So -2 all the way along to 6, and our y values go from a low value of 0 up to the top value here of 9, and this is our domain and range. Right, so the next thing to know about parametric equations is how to convert those to a Cartesian form, which we just said is a format which only contains the variables x and y. So there are actually two methods to doing this, and let's have a look at method 1, and that involves substitution. Okay, so we're going to just take E as our example here. Now what we need to do is we need to select one of the two equations, either this one or this one, and set t equals, change the subject of the formula to t. Now, to do that on the right-hand one would involve creating a square root, and that's generally not going to be the best idea. So we are going to take this one and we are going to add 1 to both sides and then divide by 2, and this gives us t equals x plus 1 over 2. We are then going to substitute it into this other side here, so y equals 2 divided by t squared, but that is x plus 1 over 2 squared. Now, having a look at this here, we've got a kind of fraction within a fraction. So what we're going to do is just sort of tidy this up a little bit. And this is our final answer, which only contains x and y, does not contain t, and therefore this is our Cartesian equation. So have a quick go at that method. So if you want to try these two here yourself, and pause the video and leave your answers in the comments below, and I'll get back to you on those. Right, so method 2. And you obviously want to use the trig identities when your parametric equations have trigonometry-based functions: sine, cos, tan, sec, cosec, etc. So what is the method? Well, step 1 is to write down a relevant identity. This is usually the hardest thing. You must have the identities, common identities, memorized. The second thing is to replace with x and y. So let's see this in action. Let's have a look at part B. So what's our relevant identity? Well, we've got sine and cosine here, but we've also got cos 2 theta, and this tells me that it's likely to be the double angle formula for cos. And one of the double angle formulas for cos is cos 2 theta equals 2 sine squared theta minus 1. What can we do with this? Well, we can go and replace this left-hand side here with our y. We can replace the other side with sine squared is x squared, and the minus 1 here. And now this is our final answer because it only contains x and y. Let's have a look at one other example, which is going to be D here, just so you've got another example. Here we've got x equals 2 sec theta and y equals 4 tan theta. So what is the most relevant identity for this one? Sec squared theta equals 1 plus tan squared theta. Okay, for this one we need to actually do a little bit more work on these two equations here. This says x divided by 2 is equal to sec theta, and then x squared over 4 equals sec squared theta. And taking the 4 tan theta, we can go y over 4 equals tan theta, and then we can say y squared over 16 equals tan squared theta. And now we're ready to place things into the identity. So x squared over 4 equals 1 plus y squared over 16. Now This can be considered our final equation because we don't actually have to have things in a y equals format unless it specifically asks. Well, I hope that's helped you, and if you like this video, then give it a thumbs up, comment down below, and subscribe to the channel for more future videos, and I will see you in the next one.